Welcome back. All right, we need to get this base shape, as annoying as it is, out of the way. It's annoying right now because it is going to be hard-coded. So drop down to the bottom of your lab class. Let me close these other windows. Close all but this. So drop down to the bottom. We're going to create a scriptable object. That's a Unity data transfer object, or data storage object is how one part of Unity's documentation describes it, or described it. We are going to use that because the front end will be a little bit more friendly. When I tried to create this class as based on interfaces, in the editor, when the editor cycles, when the editor serializes, it will wipe out anything that is not either system serializable or that is not based on a Unity object. So if it's not system serializable and it's not based on a Unity object, Unity will wipe it out. So scriptable object. Since all of our chunks will be using the same material presets, we need a copy of them down here. We do need an array that is basically, it's really the vector in reference, but I originally named it vector count reference and it's stuck around. This will be reset for each different chunk. So think about our sides. Our sides are coming in, our sides of our meshes of our models. When we import them from Blender or when we hard code them, their indexes are going to be 0 through whatever, probably 0 through 4, 0 through 6. And we need to increment that number based on how many vertices we've already put in our mesh. So if we already have one nugget in our mesh that put in 12 vertices, then we need to have a proper reference to where we put each vertex for our face indexes. And if that doesn't make sense, hopefully I will be able to make it clear in just a few minutes. All right, so I'm marking this stuff as protected because we are going to later on have some classes inherit from this class. So we need these methods to be overridable. The Xorg and Zorg is specific to the chunk. We're only working with one chunk right now, so no worries there. But like I said, the presets, those will be the same between all of our chunks. The materials will be the same between all of our chunks. So we'll have a reset later on when we have multiple chunks. Our evaluate will be called from our main codes evaluate. And we first of all tell it what the column, Y, and row of our nugget is. But we also need to tell it its X and its Z because hexagons are not square. So we need to give it some information of where everything is. We need an array of the neighbor nuggets. The first nugget in this array actually will be our nugget itself, the actual nugget we're evaluating. The rest will be the neighbors based on, terrific, I closed all those windows and now I want to jump to one of them. Based on our neighbor. object. So this you'll see is 1, so the 1 will be neighbor 0, and so forth on down the line. So I'm old, I use a lot of try and catches. Someone told me that doesn't make sense. Everybody should use try and catches. I agree. They make debugging code and writing code easier. All right. Because our hexagons are offset, or not square, should I say, we need to know whether a column, whether the column is even or odd. And we'll use it right here. So if our column is even, we actually push the row or the Z up by half of the depth of a hexagon. If it's odd, then we don't. All right, let's go ahead and write our functions here. We have a number of sides to write. Once again, protected. Nothing outside of this class should be able to call this method, but our classes that inherit from it will be able to override it. So still get my try catch in my code there. And actually we need 2 here also. So our results vertices B count is equal to x plus 0.25. So yeah, we are manually creating our hexagon. It won't take as long as you think. Egad. So this one is pointing backwards, so our normal on the Z is pointing backwards. Our normals really won't be perfect on this, but okay, so now you see me storing the V count. The V count initially is 0 when we hit this. For this nugget, nugget can be up to 24 vertices. So we're storing in the results vertices the V count, spinning through that, and then we hit down here, we increment our V count. So this really is just for each nugget. And if you want to make a nugget a house or whatever, that's allowable. We can do that with this methodology. So all right, we'll go 1F, 1F and negative, and then we want to flip that around. Oh, Microsoft's mad at me. I made fun of them a little while ago. They're very tender. Okay. Sensitive. That's the word now. So it should be 0.75 actually. we're going to come down to the bottom, and we are going to fake like we imported this. Like we already have our mesh library in place. And I will try to re-explain this right down here. Now I actually put another try catch right down here to get really specific if I have an error. Yes, this material was used. And its face indexes of wherever we're going right now at this moment is equal to the V count reference of where we said we put it in the array. So I know that is some crazy array stuff for people who don't work with arrays, but let's look at it. So we're keeping track of where we're putting the face, or where the face index is going. This is where it's going. Here is the integer of where we put it in the vertice array. So these very often will be the exact same value, but sometimes they won't. They will not be. And that's what we have to be prepared for, because we're going to import models from Blender, make them our own file format. And the best thing about doing it this way, you can let your players actually customize their code. I mean, customize their models, bring in their own models. I can't type well. So we're now doing so we just done the back side, and we're now doing this side. That's side 0, side 1. I'll keep that open for more exciting illustrations later on. We're going to keep our UVs the same for now, but we're going to change our normals on all of these. So yes, this function could be spun off, and it will be when we start importing models, but I just copy and paste it for now. So let's see here. We are going forward at the bottom, up, coming back, and bringing that around. Now we can't really go seamless between this side and this side, because it would make this very rounded and very smooth. And it would also require a lot more RAM usage. Initially, it would actually knock a RAM down if we made these two sides into one side. But you would have to have so many sides depending on how many shapes you're going to have, because this side must change its shape depending on what you put here. So if I put a half hexagonal over here, then this will be a half at the top. And that would mean that you would have to have an extra vertice on this side and an extra vertice on this side. in the end, it's not worth it. Alrighty, we're going back to the plus 0.25. This should be 0.8660254F. And that's the same for both of these. Now these two will be that again. And this will be 0. And still a negative x, but our z will become positive on this one. So Blender will calculate all that stuff for us. And hold on. No, these two are 0.25. Thought I made a mistake there, but I didn't. And we are good. I guess I should do more previews of my code so y'all can pause the film, pause the video. But see, we're already to side 3. Side 3 is directly 0, 1, 2, 3 across the front. So everybody will be this time there. These will be there. And these will be. You should not worry about figuring out how to hard code this stuff. Just follow along, and it'll become a lot more explanatory whenever we get to importing stuff from Blender. Is that right? Yes, 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 yes. Okay. I'm going to copy 2 again to make it easier on the norms. So this time, yeah, it will just, and these will be 1, and these will be 0.075. Hey, be nice. And let's see, that, and that. So is that right? Yes, the last two should be up towards the front at 0.75. These are 0.75 and 0.25, that's correct. And that'll work. Okay, now we have one last one to do, and it's mostly like 1, I believe. Trying to be one last side to do, but then we have we have to do the top and the bottom, and those have more vertices. So these will have, and let's see here. Yeah, these, the first two should be at the 0.25. No, it should be at the 0.75, my mistake. And then these two should be at 1. And yes. Yes, yes, yes. I hate spaces. Okay, So now, let's go ahead and grab 0, I guess. And let's create our top and our bottom. I definitely need my reference code over here. So, first of all, yes, this one actually stays in the same place. Yay. But, let's see here. It will point straight up. In fact, all of these will point straight up. Let us see here. 0.25, 1. This one will be, yes, at 1, exactly as I've already done. It will be at 0. This one down here will be at actually 0.8660254F. And you will be back at 0.25. So 0.25 here, let's look at it. So 0.25 to the 0 plus 0.4330172, back to the 0.25 at 0.8660254, then the 0.75, which is exactly what we have down here. Oh, I don't have a 1 on you yet. Now, have 2 more vertices on the top and the bottom. So this one will be fully at 1, but you will be at the 433. And let's see here. On the UVs, I know I'm doing the UVs wrong here. Z plus, actually just Z. X plus so this one will be X Z plus 0.4330127F X plus 0.25. Wait a minute, did I miss one? I missed one. Dang me. Come on. Be nice. Don't be mean, code. And X plus 75. And then down here, X plus 1F, Z plus 0.4330127F. No. And you're going to the 4. Did I get everything else right? 1 plus 1 plus 433. And now the last one. Okay. X plus 0.75F plus 1. Plus nothing on the Z, that's right. And that will comically create, but we need to add the face indexes. So 01203034045. A. And let's grab the 7. We'll create the 7. and everything else will go rather smoothly. Okay, so get rid of all the ones, y plus 1. And column select that, cut them, paste them right there. Now column select these. And there we go. And that's for the bottom. Oh yeah. And reverse our normal because we're pointing down. And there we go. Back up to our evaluate method. All right. Rest of this is pretty straightforward. We need to check on all our sides. Bool n0, that's a neighbor 0 is equal to our neighbors of our SN0 dot shape is equal to 0. So if it's equal to 0, then we're going to create N1, N2, N3, N4, N5, N6, N7. If we do create it, create side 0, our offset X, Y, Z presets, our neighbor 0 is our nugget itself, so we want its preset in its material for the sides. And this is so static. If you're working in business today, or if you're working in .NET as a coder or a developer or engineer, you may feel kind of dirty. Make it writing code this hard coded. But it's a lab, and we will get to do the more dynamic stuff in a little bit. So this is the top, so it's a mat. The integer in there is the material index for the top. And this is the bottom. And there we go. Our base shape is done. What did I put 7 there? My mistake, 2. Now our base shape, oh. 7 up there, I done backwards. Okay. Base shape is now done. In the next lesson, we will do the evaluate function and finish all of our functions. And then we will be almost there. It shouldn't be very long. 2 more lessons and we will have our chunk. Or in 2 more lessons, we'll have our chunk. See you there. And remember to subscribe if you're getting something out of this. Thank you.